answering questions because they have a lot of other work to do, like workshops and some other materials to do. We did made NOI Maker Space website so that the user can search the documentation and try to find the question that they are seeking for. But here also come another problem. The user has to go to the website and keep searching to get the knowledge that he wants, which means also some time for the user to search and try to find the relevant answer, which gonna take also more time from the user. So we had to find a solution for this. And before finding a solution, we had to see what we had before. What are the technologies that we have? What are the topics that we already developed before, so that we can go through it and try to use it for this use case. So we had Stuart, which is a chatbot created by Chris Meyer, and was used internally in the company to answer the question from the NOI internal team and from the customer service and so on. The idea behind Stuart is it was a RAG system chatbot. So the idea of it was you give it the data that you needed to search for, and then the robot try to search inside this data about the information that you give and try to answer using that data as a context. So at first the robot has, or the chatbot has information to retrieve from and has the context to use this information to, and generate answer based on this context and based on these informations. And this is the idea behind the RAG itself. Here's the workflow of Stuart and the RAG system as well. We have the documentation, and then we did chunk this documentation into splits, and then we do embedding for them so that we can store them in our system, and then we store them in the vector database for easier retrieval later. And here's the workflow of Reachy of Stuart. The user asks a question, did embed the query of the question of the user, go to the database, search for the question, and retrieve relevant information to the question that has been asked by the user, and then return the answer to the user. The type of documentation that was used before was the NOI internal system. So for this use case that we had to use Makerspace. So we did give this chatbot a documentations from the NOI Tech Park Makerspace and from the website of the Makerspace, so that he can now has more information to give the answers to the user. And for the Stuart, it uses mostly open source and free technologies. For the LLM model that it uses GPT-OSS, which is open source, and as well as the vector database Postgres and Python for the programming language and so on. So the system, the whole system is full open source and doesn't use any proprietary software or closed source software. And it did support some multiple languages, so that the user can ask a question in English and retrieve the answer in English, as well as German and Italian and so on. If we're gonna deep dive to the Stuart, let's say the code base and how Stuart was created, we have three main parts: the RAG system, the system that get the information and store it and try to search and retrieve the answer to the user, and the web part, which is how we can access this whole chatbot, and the scrubbers, which was created to create the database, let's say. Here, first of all, we created the database, created the vector database so that we can store the knowledge that we need and documentation that we need in the format that we can retrieve later using this RAG system. We can see that, for example, we need some important information like the files and ID, and also the starting and ending position of the chunk, because we have some chunks, so we need to know the starting and ending position for easier retrieval. If the model try to go to search, it's going to be easier to know the starting and ending and where it is exactly in the database. And so this is the database, the first step to create a database that we can store the data in. Second step, we need to load this data into this database. We create the folders, has the documentation. Documentation need to be in text file, MD file, and so on. And then we did defined the length of the chunk that we're gonna store inside and the overlap length that we're gonna store. So for each folder, we're gonna store the data, and we give it the specific chunk. So it's gonna store data with 5,000 length, and then go to the next row and store the other data, and the next and next, and so on and so forth. For this file, the query file, this is the file responsible for did the query to the database. So first of all, he get the user question, the user ask a question, so he get the question, and he go to the database, try to find context related to this question, and then when he find the context, he try to give this context and question to the LLM model that he has. So he said to the model exactly answer based on this context to that question, and then did send it to the model, and then retrieve the answer to the user as a text. Here's the web backend, how we can access the chatbot. This function responsible for trying to access the chatbot. So at first the chatbot has the website. Now we did have a post request. So user can do a post, send the question in the post request. The model gonna take the question, try to find the context, and then send to the LLM the question and context, and then get the answer and give it as a return of the post request to the user. So the user gonna send to the post and get the return answer that he wants. This until now is good. The user gonna send the question, retrieve the answer, and it's okay. Fair enough for the user. But still the user need to do some work. We need to create, like, for example, a chatbot website for the user to ask a question and retrieve the answer, and so on and so forth. And we did have another tool, another project that we wanted to make use of, which is Reachy Mini, which is a robot that has some information and has some functionalities that it can be used for. First of all, this robot can listen to the user, can see the user, and can speak to it. And it has Raspberry Pi inside it, so it is able to run a LLM model inside of it, and it's totally open source. So we did wanted to use this robot for this use case. So the starting point, we have a chatbot that we can ask a question, retrieve the answer, all as a text, and so on. We need to use another tool, which is this robot, Reachy Mini, to let's say to improve our last solution. The Reachy Mini robot, the good part of it, it's open source hardware, software, so we can create all the applications that we want and provide the functionalities that we want of trying to listen to the user and re-answer to the user, and at the same time running an LLM model inside of it. Some functionality of the Reachy, as I said, it has the degree of freedom, so he can move like around 360 and move his head and so on. It did run a Raspberry Pi, which is around 4 gigabytes, which is good enough to run some LLM models. It has mic, audio, connect to the Wi-Fi, and so on and so forth, of what a robot can contain. And it did run Python program for the applications that we can use for it. So back to our pipeline that we had before. At first let's go like laser. Okay. At first here we had the Stuart, which is we ask question, get the answer. We need to implement a new tool inside this workflow. So Reachy now gonna talk with the user and listen to the user. So first he gonna listen to the user asking the question, try to understand this question by converting speech to the text, and then give this speech text to the LLM model of the Stuart that we had before. So Stuart now gonna take the same input as he took before, but after doing some conversion and improvements, and then gonna return the answer that we asked that we had before. This answer is text, so gonna convert text to speech, and then return it as output to the user. This workflow works fine at this point. Yeah, good enough. Here is the real stack of the workflow. At first, the first stack is the local VAD, which is the file responsible for understanding and detecting the audio. So whenever the robot is running, it's gonna detect the audio that the user asked a question, and then convert this question to speech to text. So it's gonna convert to text, and then after finishing the whole workflow, it's gonna return back for the text to speech. And here's the, let's say, the documentation or the files of the Reachy. The main thing is the files contain local audio, which is responsible for getting the audio from the user. The move function was responsible for moving the robot, so the robot itself gonna move during answering the question, as well as the dance emotion, which also gonna, like, for example, move the antennas, move his head, and so on, based on the question that he answered. And the profile, which defined to the LLM model inside this robot, who is it, like giving this robot identification profile to understand exactly who is it and what is used for and what he's doing and so on, so that he has a context of what he's doing, not just a random LLM model. And of course the Stuart real time, which is the main function responsible for connecting the whole pipeline. Okay, for this is the responsible for the movement, as we can see, like left, right, up, down, and removing moving the robot in the possible movement area that it has. And the local VAD function that's responsible for getting the audio. We can see mainly here the first three the first three variables, that this function predefine some variables so that the Reachy can, for example, here the energy threshold, it's responsible for Reachy to not listen to any audios. It's gonna listen to the audio if it reaches the energy threshold predefined and above. So it's not gonna listen, for example, in the makerspace, there's a lot of noises. Not every noise is gonna fire the robot. No, it's gonna listen to exact threshold and above, so you can know that exactly there's someone talking to. And the silence duration, that you're gonna wait for if the user asks a question, and then wait for like a period to continue the question, or he just stopped the question and you're waiting for the answer. Minimum speech duration, there is a minimum speech. So for example, if you said hi, or like less was like yes or something like that, the robot is not gonna fire for these slight words. No, it's gonna wait for a real question to answer, saving some tokens and saving some time. Going next to the profile, the main thing giving to the robot so that he can understand who is it. So if you are Stuart, you are a NOI Maker Space assistant, answer the question about the equipment, booking, and so on, and respond the same language the user have asked the question, and give the answer in 3 sentences, and so on. There is a lot of some instruction, but this is the main profile text that gave to the robot. This profile, as I said, gonna make this robot answer the question that you want exactly without answering randomly to the user. Now this part is connecting the full workflow. The user gonna come, gonna speak with Reachy normally, ask the question. The wake word is gonna wake Reachy to listen, and then speech text gonna transform this speech to the text, and then going down to the Stuart. Now I have the text, do the rack system, get the context from the database, send it to the LLM model, get the answer, based on that context, return that answer to the text-to-speech model. Is gonna return, convert it to the speech, and the robot is gonna say the answer that he got. Deep diving to the main function, which is responsible for the whole workflow. First, he created the task, which says, now listen to the user. So there's task, the user starts speaking, so listen to the user, and then when you start listening to it and finishing the answer, he gonna fire, let's say, acknowledgement word, which mean I got your question, I'm gonna answer it right away, I'm gonna search for this question, okay, I got it, I'm gonna search for it, so that the user knows exactly that the robot listened to the whole question. And then after this, after saying this to the user, or while saying this to the user, gonna do the transcript, get the audio bytes that he got, that which means the speech that he got from the user, and gonna transcribe to it into the text, into the usual format of it, and then gonna send it the transcription as a content to the queue. So the queue says, now you have a question, get this question, and then we're gonna send that question to the LLM model or the Stuart workflow. Now take this transcript as the question, do your work, and then return the answer. You're gonna get the answer, and then go more down to transcript or re-transcript from the text that he got to the speech, and then first of all, you're gonna cancel the acknowledgement, gonna cancel the session, done. We listened to the question, we had the answer now, and then he gonna say the answer to the user by firing the speak function. Here's the motion responsible here to try to mimic the user answers, try to move the head, move the body based on the user answer. And here we can see that this robot is secure enough. The Reachy is secured with a, let's say, Hugging Face secure bot that got with it, and the Stuart is secure with TCP protocols, and the database is local only in our system, so everything is local and open source. So this makes the data or the question that being asked to the robot is gonna stay inside the robot. It's not gonna move anyway. It's gonna be local or inside the company system. It's not gonna. There's no data leak of sending the request to random proprietary models. And we have some latency due to lots of models. So we have a lot of models. We have some latency of sending a question to the model, and the other model sent to the another one and another one and so on. So we got some latency. This is reasonable latency. When you have multiple models connecting to each other and not all of them came from the same provider, this gonna, of course, gonna happen that you will have latency. Yeah, and this now we could go through the live demo of the robot. So first of all, we got a video in case the robot didn't work, but we're gonna try the robot anyway and see how it's gonna go. Okay. there is a slight problem with the network. So you're gonna see the video and I'm gonna try to wake up the robot. Should come from here. Can you increase the voice or the maximum? There's where's the output so that I can put the mic to it?
Sure thing, I'm on it. I'm Reachy, the friendly high-tech robot assistant at NOI Maker Space. Ready to help you with information contacts and tech-related questions. If you'd like a more detailed answer, just let me know.
Can you tell me what is Maker Space?
Okay.
Makerspace is a well-equipped workshop. About 100 machines on 400 M Sakeware. Their M squares say startups and makers can develop prototypes or small series by using tools like laser cutters, 3D printers, CNC machines, and more. If you'd like a more detailed answer, just let me know.
Who can use the Maker Space?
Let me check that for you right away. Employees with the required safety training or a signed safety briefing may use the Maker Space. Visitors need an authorized person present, and minors must have written parental consent and be supervised according to age restrictions. If you'd like a more detailed answer, just let me know.
Can you tell me how to use the laser cutter?
Interesting. Let me dig into that. Turn on the cutter, clean the lens and mirrors, place the material on the proper fixture, focus the beam onto the surface, load your design, and choose a new material preset with the correct settings. Start the job, stay present. Confirm via FabMan every 3 minutes. Keep the exhaust running, never leave the machine unattended, and clean the work area afterward. If you'd like a more detailed answer, just let me know.
Can you tell me in short what I need to know before coming to Maker Space?
Sure, one moment while I search for that. Before you visit the Makerspace, you must sign a 1-year user agreement, personal, tied to a natural person. Complete the general safety briefing, video, plus YA online test, and a specific safety briefing for each device you intend to use. Wear appropriate personal protective equipment and never bypass safety systems. Have liability insurance, deductible €500 for any damage you cause. Bring your own material or pay for it and get suitability approval for it. Be aware that you're responsible for any errors, defects, or where you notice. Understand that minors need parental permission and supervision. Accept that personal belongings aren't covered by liability and that data may be recorded for security. If you'd like a more detailed answer, just let me know. Key points: sign the agreement, finish safety briefings, wear PPE, have liability insurance. Also, bring or pay for materials, respect rules, and minors need adult consent.
Okay, great. Thanks, Reachy.
Okay. Just wait to see if the votes are still Back to the presentation. So first of all, we wanted to show the robot, but the problem mainly was the network issue. It cannot see the network here. But other than that, from what we saw from the video, the user asked the question, the steward listened to the question and then try to give the user acknowledgement answer at the first, and then try to go to the speech text and then get the answer from the rack system and give it to the user. We also saw the delay that the robot had while saying the acknowledgement word and saying the answer, and this delay due to the differences between the let's say between the models, because all the models is different from different providers, so they are not connected together. Here we can see the main things that we got from this project. First of all, we solved the solution apparently, or somehow. We can use this project as a solution to give to the external user. A user gonna come, instead of talking directly to the makerspace team, is gonna go to the robot and start talking with him and ask him the general question that he wants. Whenever he didn't find the answer, or the robot say, for example, search the web for this answer, or search or ask one of the team, you're gonna go directly to the team and ask them for that specific question, which is gonna reduce the load for the makerspace team, and also gonna answer the repetitive questions. We can see as well that in order to have a LLM model, you can have a general LLM model, but also you can do a rack system inside your company, inside your own project, so that this LLM model gonna give you the needed answer that you ask it for, specifically on the context that you provided before, which is gonna mean you have the power of the LLM model and the context of the data that you give to this LLM model. And we also see that the robots can be integrated in this bot, and we can use chatbots, we can use a robot as a companion assistant, and so on and so forth. And here's the main outcomes. One of the also main outcomes for this project was the fact that we had to create a fully open source and digitally sovereignty something, which means that this project shouldn't contain any proprietary software or any closed source software. So we had to create the project that fully open source, fully accessible to the user, and the data are secured in this way. We faced some issues, mainly the data, the quality of the model. The closed source model is fair enough, is good and better than the open source models, but this doesn't mean the open source model cannot provide the minimum required for the project. But we did use an open source model which gave reasonably good answers, as well as the fact that using an open source model, you have two options, whether to use them online or to use them as an API request, or to use them locally. It's even better to use them locally, but due to the lack of hardware for this robot, the robot has Raspberry Pi, which, yeah, it can run LLM model, but it's still not powerful enough to run the whole LLM model. So we had to use the API request and so on and so forth, which is good for this project. But for later acknowledgement, if someone has its bigger machine, he can run the whole open source model inside its machine. And yeah, this was the main outcomes that we got from this project, connecting these two workflows. And as the message from NOI Park, everything is open source. So this project is open source. Related, the Stuart is open source. We have two models. The main model coming from Chris Maya that had been created before, and the second model, which is ragged on the new data of Makerspace, as well as the Reachy Mini. This Reachy Mini is cloned from the main conversation app coming from Hugging Face. And fair enough, every repository here is open source, so you can go for it, you can search for the code and try to go around it. You can edit it, you can clone or the Stuart, whether the main Stuart repository or the Makerspace one, and try to go around it, create your own chatbot and provide it with your own data and do the rack system. If you have a robot like that, you can also run a simulation, not just the physical robot, and play with it. You can use this Reachy Mini repository, as well as you can create your own app, search for the conversations app and create them and go around them. And yeah, we are early enough for this presentation, but we are now open to the question if someone had any question regarding Stuart, Reachy, and regarding the whole workflow.
Thank you, Abdullah. So
I'm interested in the part where you're doing the emotive stuff during the text-to-speech. Like, how exactly does it work? Do you do a part of text-to-speech and then you do the emoting while it? Like, how is it synchronized? Because you said you're using special tokens or stops.
So you mean while he tried to answer, he moving this part, or what exactly you mean?
Yeah, exactly. Because you wrote that that you added some special markers or whatever in the text-to-speech to do emoting.
Yeah, but the idea of the text-to-speech, he's moving while trying to giving the answer, and the movement rely on the, let's say, the energy of the speech that he's saying. So he's saying a text, and this text, when he's in audio, it's has energy, and based on this energy, he's gonna move his head, gonna move his antennas, and so on. So it's not related exactly to the text itself, but related to the energy. For example, if he's saying a funny thing, so it has an energy of speaking, so he's gonna move the antennas in a funny way, and so on with if he's angry or if he's just giving a neutral answer and so on. But it doesn't exactly rely on a moment of text to speech or speech to text, because the whole pipeline works like from the acknowledgement answer until giving the user the answer. This whole workflow work in the backend, and then the Reachy gonna start acting while after getting the answer, which is the text to speech. So it's gonna get the answer text to speech, and then it's gonna talk and move and so on. So it's not fairly connected from meaningful of the text, but we can say from the energy of the speech itself.
Okay, thank you.
Yeah.
Energy means how loud I speak. So if I shout to it, it will know I'm angry.
Yeah.
Ah, okay.
Yeah. Okay.
someone else has questions or?
Okay.
Ho capito quello che hai detto. Fantastico.
Okay, great.
E
Non parlo inglese?
a little bit,
Okay,
not so
okay,
much.
Can try and translate. Okay.
E allora, praticamente ho visto che hai fatto un prodotto incredibile, ok?
Grazie.
Volevo chiedere se già stai pensando anche a altri modelli,
Mm-hmm.
o se verranno altri modelli e quali funzionalità avranno in più.
So they asking if there's another models doing the same thing, or
Yeah, the question was, first of all, you did a great job.
Thanks, man.
So amazing. And he is answering if you are planning to integrate other models or evolving the models with new features. And
yeah, this mainly gonna depend on the next stage of the project. We did tested some models. I guess we have it here. Okay, fair. Okay, it's not included here, but you can see it in the. Let's. Okay, we can see it in the main repository because I don't think we have the network to go through it. But yeah, I did experience with some models. which work with it, and some other which has the problem of the hardware that we have in this robot. So we could improve it. We could use another models, but this mainly depends on two things: the project future and how this robot gonna handle these models of the hardware requirements and so on.
Thank you.
Yeah, welcome. Okay.
Did you test this product also with some users, and did you get also some feedback on the usage of it?
No, we did use it internally now, and this may be the next step to use it mainly in the NOI Maker Space, or depending on the future of the project, as I said. But this is now just a demo of the concept of having this model, this workflow, this project as a solution to the main problem of the makerspace. So maybe the reasonable next step is to try to use it in the makerspace or try to use it internally more into the company system. So this also may be a future plan to do.
Okay, yeah, I was asking because having a humanoid robot gives also some emotional stress on what on the answers of the of the models.
Okay.
And yeah, it is much better, in my opinion, instead of reading them in a screen. So
Yeah, of course, yeah.
that's why I was asking. Thank you.
Oh, okay, you're welcome. Great.
Yeah, as Abdullah told, we are planning to put it there. But as Abdullah stated during the presentation, we have a problem with some missing documentation, or some documentation is only in one language. So the colleagues, I think, are collecting all the documentation, improving them to let the models interpret it properly and provide to the users a better user experience. Otherwise, we risk to burn out the technology because of missing documentation, and we would avoid that. So that's why we didn't test it with externals and only with internal people and selected users.
Okay. Great. Okay.
Thank you.
Okay.
Congratulations for the project.
Thanks, man.
I found it very interesting, and I have a question. You mentioned that the robot can see, but which is the purpose of this capability? What can it see, and how it changes his behavior with respect of what he's seeing?
Of course, yeah. So this is a general robot created from Hugging Face and Bolin Robotics. So it has all these functionalities, but for this project, we didn't exactly use this feature of seeing. We could use it, for example, to take the robot and show him, can you see this machine? Can you tell me about it? But this more advanced feature of analysis the see and so on. But for the main purpose, or for the main application that came with the robot, it can see the surrounding and can describe it based on the general sense of saying, yeah, this is a human, he's wearing a black t-shirt and so on, but not on the details, because the details gonna require more advanced analysis of the computer vision and the image processing and so on. So you can say this is a capability inside it for the general user, or even more if this project, if we had to do it or wanted to do it as external feature.
Yes, I was asking because I developed a module for human-computer interaction.
Okay.
Now it's for it's to improve the communication between a robot and a human.
Okay.
It's a computer vision module that detects the emotion of the human. Okay. So it can be useful to detect which emotion the human is having between the interaction. It's based on the face expression. So if I make an happy face, he detects that I'm happy.
Okay.
This could be interesting because the robot cannot see your face, and it can inference your emotional state only on your words, and it can be a limitation. Of course, maybe not for this robot because it has a specific purpose of providing basic information. But I was thinking about it in a more general way of seeing an assistant.
Yeah, thanks for this project and the great project that you did. As I said, this robot, it has this functionality, but not for this project. But still, there's also random projects on the web that use this for example, the face detection and seeing the user if it's happy or not, and so on and so forth. But this is not used for this project. But if you can, we can talk later about this the project
Yeah,
that you
it's
did.
open
And can,
source.
yeah, and can see the project and how it's working. And this could be a great thing for me since I'm also doing data science. So this is an interesting project for me. So yeah,
Of course.
thanks for this.
Thank you.
You're welcome.
Did you try German and Italian?
Yeah.
How did it work? How
So
well does it work?
Yeah, it worked, and the accuracy in German was more than Italian because lack of documentation. The documentation was provided mainly in German and English, and there was little documentation in Italian. So it should be language independent, but he answers in the context. Mainly what we got, the user gonna ask a question, and this question is gonna go to the steward itself using whether English or German. So you can ask in Italian, but you're gonna search for the language and return it mainly in English or German. You're gonna answer in Italian, but using the test that we did, at some time he gonna just go for German or just go for English. So this is some, like, let's say, a throwback from the lack of documentation. But it did, Stuart, as you said, it has the language independent, and also Reachy just transformed the text to speech and speech to text. So if you talk in Arabic or another language, you're gonna transform it.
Maybe it's just a prompting problem, so that you insist that he really tries to answer in the user language. It should do it, because when you are at the point where you assembled all the pieces and query the LLM, there is no language anymore, right?
Yeah.
So maybe the original Stuart has a very specific prompt where it forced it to answer in the user's language. And maybe that piece of prompt
Maybe this
has to be added in a later part of your pipeline. So from my feeling, is it the problem goes away if you just do some clever prompting at some point. I have the suspicion that this gets lost because you have this long pipeline with steps, and somewhere the prompt gets lost that you should
changes
use,
between the
and
models.
then it switches language, and you get a bit of a mess.
Yeah,
I don't think it's the root of the problems. I don't think it's the lack of the documentation in the proper language. So I think it comes out on the later stages.
Okay, great. Maybe this.
By the way, this is really great. I like it.
Thanks a lot. Yeah, thanks for this, and yeah, maybe this is also the problem, as you said, because also Reachy is is separated from Stewart, so and there's also a lot of models, and each model has its own prompt, so maybe there's communication between the models, and this may be the problem. And thanks for this suggestion. We can look for it in the project later.
It seems that all questions have been answered.
Okay, great.
So if you can switch back to my presentation.
Yeah.
So Abdullah, thank you. Thank you for your great presentation and your great contribution to develop this project. Today Reachy was a bit scared about the people, but maybe later on we will be able to reactivate it and show you. Before concluding and enjoying the networking part and the beer, the left drinks, I share the next upcoming events. The next edition of the Software Developer Thursday will be the 2nd of July. René Lambert will present a BPM man tool mainly based on public sector processes. Then we have still 3 free slots for this year, the 6th of August, 3rd of September, and 3rd of December. So if you have Chris already tells me that he won't present, but we never know. No, jokes apart, if someone is interested to share his experience or his project, we will be happy to find a date. So just drop me an email, s.seppi@noibit.it, and we will find a date and define everything. Then the last point, last but not the least, the SFSCon 2026 started his process and opened the call for speakers. So you have time till the end of this month to propose a talk, make a talk proposal. You find everything on the sfscon.it website under the call for speakers section. And also there, if you have something interesting to present about free software, make a proposal and we will be happy to evaluate it and insert it in the program. So thank you all for coming. Hope to see you next time, and thank you, Abdullah, again for your presentation.